Hi, I'm Sean Reardon, and I'm going to talk to you today about educational inequality. So I don't know if I'm going to answer David's question about why there's so much inequality, but I do sort of hope to shed a little bit of light on the relationship between schooling and educational inequality in terms of academic achievement, which obviously then has implications for access to college, which we'll hear about from some of the other speakers, and ultimately success. So I guess think of this as sort of earlier in the life course than some of the other stuff, as a way of thinking about the processes that lead to inequality. So let me start by telling you this story. So when I was 22, right after college, I went and taught high school on the Pine Ridge Indian Reservation, which was at the time and still is today the poorest county in the United States. And I taught there for 2 years, and then I ended up teaching in an affluent suburb in New Jersey, Morristown, New Jersey, which was in many ways about as far in America as you could get from Pine Ridge. And so I didn't actually deliberately choose this. It was a series of circumstances that ended up this, but I was sort of struck as a 25-year-old by the enormous disparity in the communities, in the educational opportunities, and the general opportunities that children had in these two really different parts of America. And so I spent a lot of time then when I was teaching thinking about this and trying to understand how much was this about the schooling system, how much was this about broader social inequality, how much is it about segregation, and I've sort of been thinking about those questions ever since, and in some ways that's kind of what leads me to do the work that I've been doing lately. And so one of the things you'd like to be able to do is sort of be able to compare the educational opportunities and outcomes across places like Pine Ridge and Morristown or anywhere in the United States. And it turns out to be more difficult than you'd imagine, even though you might think, well, we give kids a lot of standardized tests. We should be able to compare test scores and sort of get a sense of outcomes compared across the United States. But the problem is that although we give a lot of tests, we administer something like 50 million standardized tests a year to students in the public schools in the United States. But each of the 50 states administers its own test. They administer different tests in different grades. They administer different tests in different subjects. And so within 1 year, there's about 600 different standardized tests being administered in elementary and middle school. And those tests differ not just in sort of content, but they're also sort of scored differently. And the definitions of what counts as proficient or advanced or basic differs across the states. So it makes comparing academic achievement in schools in different states almost impossible. I say almost because I'm going to show you quickly sort of a way that we've tried to get around this problem. But essentially, knowing that 63% of children were proficient in Palo Alto and that 41% of students were proficient in Boston is utterly uninformative about whether or not students in Palo Alto have no more math content than students in Boston, because the tests are different, they're scored differently, the passing threshold is set differently. And so you sort of have a giant pile of not very good data. It's sort of like the old Woody Allen joke where he goes to a restaurant and says, well, the food was terrible, but at least the portions were large, right? So that's kind of the sort of test data situation we have. The data are terrible, but there's a lot of them. So the solution that me and my colleagues have sort of done to sort of approach this is, and there's one slide, I'm going to tell you what sort of 4 years of work. So essentially we take the counts of children who score below basic, proficient, and advanced, because that's how the test scores are reported. Many states don't actually keep the individual student underlying scores. They sort of report public counts of kids in proficiency categories. We take those counts and we fit a heteroscedastic ordered probit model, which is basically we just assume that every school or school district has a normal distribution of test scores. And we estimate the mean and the standard deviation of those distributions of test scores that would be most likely to give rise to the observed counts of kids falling in each of those categories. And we do that separately within every state, grade, year, and test subject, because within any cell like that, everyone takes the same test. And that lets us compare the achievement of kids in one district, grade, subject, and year to another one in the same state, grade, subject, and year, right? So that lets us, say, compare third grade math scores in 2012 in Palo Alto to third grade math scores in 2012 in Berkeley, but it doesn't do much for us across states. Then what we do is we say, we know where each school district falls in the statewide distribution of test scores. And we have the NAEP scores, the National Assessment of Education Progress, which is the same test which is given to representative samples of students in every state every 2 years. So we know how to compare the states to each other on a common test, the NAEP. And so we say, if you fall at the 23rd percentile of your state distribution, where would that put you on the NAEP scale? So we sort of put you at the same place on the NAEP distribution. And that allows us to then kind of get the scores in the same place. Then we do a lot of work to validate that. So you might think, well, that's probably not going to really work well because there are all these different tests and how are they going to line up? And so what we do is we compare what we get. We say, what do we think the test scores in Los Angeles are on average if they had been given the NAEP test, right? Because that's what we're doing. Well, it turns out that NAEP actually gives the NAEP test to representative samples from 20 large districts in the United States. It's called the TUTA test. So we actually know how kids in Los Angeles in fourth grade in 2011 did on the NAEP math NAEP test. So we compare our estimate, which is not based on that sample. It's based on kids taking the state test and then us equating it to this NAEP scale. And we say, how close did we get? And we get very close. On average, we're off by about 0.05 standard deviations. Correlation of the means we get to the NAEP means is about 0.97. The correlation when we look at trends across grades is about 0.8. So we do a good job, and we do a number of this kind of validation checks using different audit tests, essentially the same test given in various places, and we see do our methods give us the same answer when kids take the same test in different districts across the state. So that's a very short way of explaining sort of how we do this, but people always ask me, how do you make these numbers? And so I want you to sort of know where the numbers come from. And then we standardize all the test scores to the sort of national NAEP distribution, and I'm going to show you them today in terms of essentially sort of grade equivalence. So on average, kids' scores go up by about 11 points on the NAEP scale every year, and so I'm going to sort of divide everything by 11, so everything's in kind of grade equivalence numbers. We also can do it in just standard deviation units or something, but the grade equivalent scale is sort of easier to interpret. So that's where the data come from, or how we analyze the data. And then the data we have is data that are collected by the US Department of Education EdFact system under the No Child Left Behind policy, which was in place until December. Every state had to test every kid in 3rd through 8th grade every year in math and reading, and they had to send all those data to the Department of Ed. And the Department of Ed then had a room with a giant pile of data in it that they didn't do a lot with, from what I could tell. And so I worked with them for a while to get them to make the data available and then get permission to release public estimates based on those data. So that's what I'm going to show you today. The raw data has no suppression, so if there's two black students in 3rd grade in George Washington Carver Elementary School, we know their scores. So there's no suppression in the raw data. In the versions I'll show you today, we suppress cells with fewer than 20 students. These data are based on about 215 million test scores that are given to every 3rd through 8th grader in public schools in the United States from 2009 to 2011 in math and reading. It covers all 50 states and DC. It covers all 12,000 plus public school districts in the United States in those grades, years, and subjects. And you can think of it as covering 10 cohorts of kids who entered kindergarten in 2000 to 2009. So it's a lot of data. So with all that, let me just make one caveat here. So these data are not yet available for public dissemination. So if you are from the media You may not report on these yet. They'll be publicly released sometime in early May. We're going to put the data up on the web so people can use them and do all kinds of analyses, we hope, with them. But for now, this stays here, please. Thank you. All right, so what do we know? Well, so let's look at the two places I taught high school since I started with that. So if we put all school districts, we measure their socioeconomic status, and we measure their achievement on this sort of grade levels above or below the national average. So 0 here is sort of a school district is at the national average. Pine Ridge falls about 3 standard deviations below the national average in terms of its socioeconomic conditions. It is extremely poor. And Morristown falls about 2 standard deviations above the national average. So the two places I taught actually are really quite different in socioeconomic conditions. And Morristown students score about 2 grade levels above the national average, and students in Pine Ridge score about 3 standard deviations below the national, or 3 grade levels below the national average. But we probably shouldn't make any conclusions about educational inequality based on the 2 places that I happened to teach 30 years ago, so let's look at the whole country. So this is a map of every school district in the United States. Purple indicates sort of below average test scores, and green represents above average test scores. This is Pine Ridge, right here. That's Shannon County, South Dakota, now called Oglala County. And Morristown is somewhere in that indecipherable part of southern New Jersey. So you can see there's a lot of heterogeneity across the United States in terms of average test scores. There are places, in the South and the West where test scores are 2 to 3 grade levels below average, and then there are parts of the country where there's a lot of green. It's somewhat hard to see the fine detail at this level. Around metropolitan areas, school districts are really small, so you can't see them so well on this map. But there is heterogeneity in these places, but it's at this scale it's hard to see. So how does academic achievement relate to school district socioeconomic status? And one way to think about this is there's this sort of ongoing debate in the education world and in the sort of inequality world about how much should we expect schools to be able to undo broad social inequality. And one side of that argument says, poverty is really powerful and it's sort of beyond the capacity of a single institution like schools to sort of undo all the damages of poverty. And the other says, we can build high quality schools. Schools are the best institution we have for undoing the effects of poverty, and we can sort of break the mold kind of schools that will sort of undo that. And I'm not going to give you the right answer to that today, but I want to sort of suggest that the data can help us think about that. If it were possible for school systems to sort of undo poverty, we ought to be able to find some school districts in the United States with relatively high levels of poverty, but also relatively high levels of academic achievement. So let's see if there are any. So this is all 11,000, 12,000 school districts for which we have estimates. On the bottom axis is the measure of the socioeconomic status of the population in the school district. I should say this measure on the x-axis is based on American Community Survey data. So the census does a special tabulation of the ACS, which tabulates the ACS data within school district boundaries for the population of families who have school-age children enrolled in public schools. That is, these are not sort of kind of rough proxy measures. These really are the sort of census measures of the socioeconomic status of the families who have kids enrolled in the public schools living within a school district. And so this is a composite measure of family income, parental education levels, poverty rates, unemployment rates, single-parent household rates, SNAP receipt rates. I think that might be it. So this, and it's in standard deviation units of the sort of distribution of school districts in the country. So what do you see in this picture, apart from that it looks like the Andromeda Galaxy or something? There's a couple things to notice. One, there's a lot of variation on the vertical axis in terms of the average levels of student performance across school districts in the United States, with some school districts scoring sort of where students perform at roughly 3 grade levels above the national average, and some school districts performing 3 grade levels below the national average. Think about what that means. That means if you sort of compared the performance of 2nd graders in one district to 8th graders in another district, they would be comparable. It's not exact, I mean, you have to be a little careful about these kinds of grade level comparisons, but that's kind of roughly the order of magnitude from the schools at the bottom to the schools at the top. So there's a huge difference in academic performance. The second obvious thing to notice is the really high correlation between the socioeconomic conditions in a school district and the average performance of students in the school district. That student level correlation here between your district socioeconomic composition and your district's average test score is about 0.85. The district level correlation is like 0.775 or something like that. So a very strong correlation, which is to say there aren't a whole lot of really poor districts where students score at or above the national average. We don't have a lot of evidence of kind of break the mold school districts that solve the problem of concentrated poverty at scale. Nor do we have a lot of evidence of school districts serving high concentrations of affluent students where students don't do above average or well above average in general. So that suggests, on the one hand, that if you sort of think about school districts as kind of the laboratories of educational innovation, we have 12,000 of them, they're all doing different things. There's a lot of autonomy in school districts to do different things. If you think about them as laboratories of innovation, you would hope that some of them would have sort of figured out how to solve the problem of helping kids achieve high levels of performance at scale under conditions of relatively high poverty. And there's not a lot of evidence that we have that. There are some, that are kind of in the bottom third of the distribution of socioeconomic status, and at or near the average, the national average. So these are the empirical Bayes shrunken versions of these scores. They're really precise by and large. When you show the unshrunken versus the shrunken, it's almost unchanged except for the really tiny ones. Part of the reason for that is even in a really small school district, say that has only 20 kids per grade, this is based on 60 cells of 20 students per grade average. So it's 6 grades, 2 subjects, 5 years. And so this sort of smallest cell here is based on 1,200 kids. And so an estimate of the average for 1,200 kids ends up being pretty precise. The reliability of the district level means is in the 0.95 to 0.99 range. So there's very little, certainly some of the super tiny ones have standard errors that are, non-trivial, but most of them here are pretty precise. When we estimate the sort of variance around this line, taking out the kind of error variance, the standard deviation around that line is about 1 1/4 grade levels, about 0.4 standard deviation. So there's real variance that's not just attributable to kind of idiosyncratic sampling variance. So that's really my second point, is that even though there is this strong relationship between socioeconomic conditions and test scores, there's still meaningful variation. There are school districts, serving the same proportions of, the same populations in terms of poor and non-poor kids, where students are scoring as much as 2 grade levels different. And so that suggests there really is something to learn from the school districts that serve high populations of poor kids, but do much better than comparable places elsewhere. So that understanding the sources of that real variation seems like a crucial thing to trying to figure out how much can schools do and what is it that they can do. Even though it's important to acknowledge that there's this really strong relationship, there's no evidence that sort of at large scale we've been able to sort of solve this problem. If you look at the 100 largest districts in the United States, so these are big places where there's no sampling error in these estimates whatsoever because they're giant, but there's still a lot of variation even among large urban districts serving relatively poor populations. That's New York City, that's Los Angeles, that's Chicago. So 3 places that all serve relatively poor populations, but you know, the Los Angeles, New York City difference in average achievement is about a grade level, right? It's not trivial when you're talking about 1 million kids in Los Angeles and New York and 750,000 kids. So understanding sort of what we can do at scale that makes sort of outcomes better in one place than another is important. So this sort of looks like, if you look at the standard deviation around this line for the big districts, it's about the size of what teacher value added estimates are for the variation in teacher value added estimates. Now, this isn't to say that these differences are all caused by the school district, because they may be caused by differences in community conditions that sort of aren't captured by the socioeconomic stuff we have in the model. But another question is sort of how much of this is really at the district level and how much of this is because states really differ. And so, since we're in California, the red dots here are the 700 or 800 or so school districts in California that serve elementary and middle school kids, and the white dots are the districts in Massachusetts. And what you see here, I think, is quite striking. In California, school districts that serve low and middle income kids students in those districts do much worse than students in comparable districts in Massachusetts. So a lot of the variation here isn't sort of just because San Bernardino or whatever this is hasn't much, is sort of different than Boston, but it's because California is sort of different than Massachusetts. And so what is it about state policy, early childhood education, things like that in states that makes this difference is one of the questions we're looking into. Now, obviously, California has a large proportion of English learner students, so there's different populations, but even controlling for a lot of things like spending, like English learner students, things like that, there's still a sizable difference between the Massachusetts average scores conditional on socioeconomic status and the California one. So it's not strictly about demographics or spending, though those things do matter. So the next thing I want to sort of say is, okay, this is sort of the average test scores in the district, but what if we want to know in which districts are student scores growing the fastest from 3rd to 8th grade, right? Remember, we have 6 grades of data, so we can look at trajectories across the grades. And so when we look at that, now the y-axis here is how many grade levels do students grow on average across the grades within a district. So 1 would be the national average. Obviously, you grow 1 grade level a year. And higher than 1 is faster than average. And here you see evidence of a slight relationship between socioeconomic conditions and growth rates. That is, kids' performance is increasing faster across grades in the more affluent school districts and slower across grades in the poorer school districts. And I've highlighted the 100 largest districts. The pattern holds for them as well as for the whole thing. So you might be interested in that. That's Chicago. And so when I first made this graph, I thought, really? Kids in Chicago are growing like 20% faster across grades than the average in the country, even though Chicago is relatively poor and it's big. So do we really believe this? So Chicago conveniently is one of the districts that the TUDA test is given in, and so TUDA is the NAEP test, and it's the same test given every year, and so it makes it possible to compare the growth rates across grades and years in those TUDA districts to each other. And if you look at the TUDA data for this same time period, Chicago stands out as a big outlier in the TUDA data as well. That is, Chicago has the fastest growth rate across grades in the TUDA data, just as it does in our data. So this I think is real. This is not a sort of a error induced by our equating method. But one thing this picture suggests is that remember the picture before showed you that average scores are higher in more affluent districts, but this says they're also growing at a faster rate. So that sort of suggests inequality between districts is actually increasing as kids get older. This is California versus Massachusetts, and here we don't see the difference, right? So students in California are growing at the same rate across grades, conditional on their socioeconomic status, as students in Massachusetts. So the difference doesn't seem to be in rates of growth in the school year, but more about kind of initial conditions or performance and grade, the performance that kids have before they get to grade 3. So it's not sort of unequal growth rates that's producing this California-Massachusetts difference, but something prior to grade 3. But that could be, that could be schooling, that could be family background, that could be community things, could be preschool availability, any number of things. If we look now at the, so this is like the first picture I showed you where this is just average achievement, not growth on it. But now I've taken away all the dots and I've just drawn the regression line for the 6 different grades if we sort of estimate them separately. The black line, which is hard to see here, is the relationship in grade 3, and the whitest line is the relationship in grade 8. And so you can see this tilting, that is the relationship between the district's socioeconomic conditions and the average test scores of its kids grows stronger over time. And it grows stronger by roughly, I forget the number, I think it gets about 20% steeper over those 5 grades. So that's a sizable change. Now that may just be a continuation of the trend that produced the initial changes, right? And it could be caused by things outside of the school system. It could be caused by inequalities in school inputs and things like that. Again, hard to, I can't say from this, but what it does say is that this pattern of relationship between socioeconomic conditions and achievement gets stronger across the grades. The next thing we look at is we look at what happens to this relationship to test scores across cohorts. So remember, we have 10 cohorts of kids who enter in 2000 through 2009, enter kindergarten in those years. And so this is the average growth. So zero would mean districts sort of stay at the same level across those 10 cohorts. And positive means their test scores are going up in an absolute sense. Because the NAEP scale, which we anchor it to, is the same test over time, we can sort of measure absolute change because the NAEP scale measures absolute change. And what you see here is that on average, test scores have gone up. They go up by about a 20th of a grade level per year. So that's about a half of a grade level over the 10 cohorts we have. So that's non-trivial change. It's consistent with the long-term trends in NAEP, where we've seen 13-year-olds, 9-year-olds today have test scores equal to 13-year-olds, or 11-year-olds, 2 years ago, 40 years ago. So there's been a kind of a long-term trend, and you see it in the data here. 40 years ago. What's that? Yeah, I screwed it up, so let me say it again. So 9-year-olds today have test score performance that's roughly equivalent to 11-year-olds 40 years ago. 40 years ago, 1978. So you compare scores today to 1978. So sort of 2 grade levels of change over 40 years. 4, yes, not 4. 4 would be really phenomenal, but no. Yeah. So people like to say schools are getting worse, but if they are, it's not showing up in performance because performance is going up over time. The other thing to notice here is that the relationship between growth and performance over time is relatively flat with respect to socioeconomic conditions. That is, except at the very, very, very poorest places, on average, achievement is going up at roughly the same rate in school districts with different socioeconomic conditions. So there's not a widening of the inequality or the disparity sort of between rich and poor districts over time. Here it is for Massachusetts and California. And again, there's no real difference in the growth rates across time between Massachusetts and California. So it's not It's just that California is sort of behind and staying behind. And if we draw this relationship for the 10 different cohorts, black is the earliest cohort, white is the latest cohort, you can see that average achievement has sort of gone up pretty much everywhere, except sort of at the bottom end where we're not seeing the achievement go up. And that makes sense given the other thing. So this is sort of a very high-level descriptive picture of some of the patterns of average achievement across school districts and their relationship to socioeconomic condition. The next thing I want to show you and to end with is just some stuff we've been looking at achievement gaps, because not only do we have the data for the whole population in any given grade, but we have it broken down by race. We have broken down by gender, free lunch status, a bunch of things, but I'm just going to show you the race stuff today. So we can look at racial disparities in academic achievement in every school district in the United States, at least every school district with sufficient numbers of white and black students or white and Hispanic students. So that's what this picture is. So I'm limiting here to school districts with at least 200 black students, just to focus on the places where the vast majority of the black student population is. And on the y-axis here is a measure of the white-black achievement gap in each school district, measured in standard deviation units now, not grade levels. So one standard deviation is a really sizable gap. It's just like more like 3 grade levels in the metric I was using before. This axis here, 0 means whites and blacks in the school district have equivalent socioeconomic status. To the right means whites have higher socioeconomic status, and to the left means blacks have higher socioeconomic status. And again, it's the same socioeconomic status composite I used before, the composite of all those census variables, but separate for each group. And you can see, first of all, in most every school district, except for a few, white students have higher socioeconomic conditions than black students. That's not surprising because that's the national pattern. You can also see there's a lot of variation in the size of the white-black achievement gap across school districts. In some places, it's more than 1.5 standard deviations. In other places, it's near 0. There is only one place of any meaningful size where the white-black achievement gap is 0. Anyone have an idea what that place is? Shout it out if you know it, or if you think you know it. Did I hear Chicago? All right, any other guesses? Atlanta? That, my friends, is Detroit. So Detroit has really poor whites and really poor blacks and really low achievement for both whites and blacks. If I went back to this picture back here, that's Detroit. Okay. In the national distribution, it's about as poor as you get and about as low achievement as you get for any place of any size. So, and that's true for whites and blacks. They're all equally poor, and students are performing quite poorly on tests. So that's Detroit. This is Clayton County, Georgia, which is poor but not super poor, kind of a little, sort of below average, and has a largely black population, but a non-trivial white population. But other than that, there's sort of nowhere of size that's got achievement gap anywhere near 0. The third thing to notice about this is there is this strong relationship between the racial difference in socioeconomic conditions, so places where blacks are much poorer than whites, you have, on average, a bigger achievement gap. That's indicated by the slope of the regression line. But even in places where whites and blacks have the same average levels of socioeconomic conditions, the achievement gap is still roughly 1/2 standard deviation, so still quite big. That is to say, socioeconomic conditions are not the whole story. And places that have students of equal socioeconomic conditions have not eliminated the achievement gap, other than Detroit, which has sort of done it through a kind of a race to the bottom. So I'm not sure that's the model to emulate. And what about these places? What are the places with really big achievement gaps? I think you might have seen it because I flashed the slide, right? So I won't ask you, but. So the two big ones, Washington, D.C. and Atlanta, have very big very big racial disparities in socioeconomic conditions and very big achievement gaps. But first place for the largest achievement gap, and these are shrunken, so there are a few places with bigger ones, but they're really imprecise. So when we do the shrunken estimates to kind of get rid of those imprecise ones, Berkeley has the largest black-white achievement gap of any school district with 200 black students in the country. Palo Alto's not up here because it doesn't have 200 black students. But its achievement gap is sort of in the greater than 1 range, I think. I looked at it last night. So it's not doing great. The other places with big ones are interesting places. Evanston, Illinois, Chapel Hill, Berkeley. What's common about those places? Those are like the places that you and I spend a lot of the rest of our lives in, right? I mean, these are the places where people like us live and work. And so that's really troubling. They have much, much higher achievement gaps than you would predict based on the racial disparities in socioeconomic conditions. They have big racial disparities in socioeconomic conditions. They have much, much bigger achievement gaps than you would predict. And so John Diamond and Amanda Lewis have a new book out called Despite the Best Intentions, which is like a kind of an ethnographic case study of one such school district that's a kind of affluent, mixed race community that has very big achievement gaps. And so if you're sort of interested in thinking about that, that's one place to look at. I mean, and in their story, a lot of it is due to kind of unequal opportunities within the school system that are sort of subtle and not intentional, but create really different tracks and different sets of opportunities for black and white students, even in a context of kind of substantial affluence. We can look at the same thing for the Hispanic-white gap, and the story is relatively similar. The white-Hispanic socioeconomic differences aren't as large on average. There's more places where Hispanics are equal or even slightly more advantaged than whites. The range of achievement gaps is still quite big, and even in places where the socioeconomic differences are near zero, you tend to have an average achievement gap about 0.4 standard deviation, so a similar story. There are some places where, again, the Hispanic white achievement gap is zero, a few more of them, and I looked up last night which these were, and now I no longer remember. And then, again, there are places with big achievement gaps. Which are they? Well, Berkeley is up there. Palo Alto's up there. Menlo Park down the road. And again, Chapel Hill. So again, you see some of the sort of college towns and similar sort of story places that have relatively high Hispanic white achievement gaps, even given the socioeconomic disparities. And so again, trying to understand that. Now, we've done some analyses, and with this, we've done some analyses to try to look at what features of school districts most predict the achievement gap sort of net of socioeconomic conditions. We've looked at funding, the presence of charter schools, the proportion of minority students who attend charter schools, differences in teacher-pupil ratios and resources that schools have. And we've looked at segregation. And by far the biggest predictor of the deviation from this regression line is the level of segregation in the school district. And in particular, it's one particular dimension of segregation. That is, it's the extent to which white and black or white and Hispanic students attend schools with different levels of poverty. So that's the best predictor of the achievement gap, net of all the socioeconomic stuff and everything else in the model. Places where black and white students go to schools of very different levels of poverty on average are the places that tend to be sort of above that line, and the places where they go to relatively more equal schools in terms of poverty. And so that suggests that school poverty is a limiting condition for school quality. It is not itself school quality, but it suggests that school quality is sort of well proxied by school poverty, and it may be sort of a limiting condition, and that may be very hard to create equal schools in a system that's where racial segregation is lined up with socioeconomic segregation, and therefore blacks and white students are going to schools with different levels of opportunity. So we're still sort of working on that. We have 1 or 2 papers that we'll be putting out soon on the achievement gap stuff and the segregation stuff. And we'll be releasing the district level data that I've shown you here sometime in early May. So I would encourage you all to go do some work with it. So I think we have time for questions, right? Yep.
They do worse, the gap is larger in those groups?
No, it's the opposite. So here I'll show you a different picture that's sort of like this. So these are not districts; these are metropolitan areas, but the picture is the same basically. And so this is on the x-axis here is not differences in students' socioeconomic backgrounds. This is differences in their exposure to school poverty. So 0 is a metropolitan area where on average white and black students go to schools that have roughly the same levels of poverty. And big numbers mean that black students go to schools that have much higher levels of poverty than white students do on average in a metropolitan area. And this is the achievement gap on this axis. And so the interpretation is that achievement gaps are larger when black students go to high poverty schools and white students go to low poverty schools. That is when segregation is lined up with differences in exposure to poverty. This picture looks essentially the same if we do it at the school district level rather than the metro level. And this relationship holds conditional on all the socioeconomic disparities that are in the earlier slides. This is an unconditional picture, but the relationship is still there and significant when we control for everything else. Right. Yeah, though I didn't show you anything here about schools. Remember, this was all district stuff. We have school level data. It'll be some months before we release that, because there's 80,000 schools and they're smaller samples and there's a lot of complexity around it. But we will eventually have sort of school level data for schools that have at least 20 kids per grade, or 20 kids of a given race per grade, or for the race gaps stuff. Betsy?
Thanks. I really appreciated what you showed here. This is fantastic. I was wondering, in the quest for finding sort of standout schools that serve poor kids better, I'm wondering if that might be hampered by the endogeneity of school choice and the fact that affluent parents who can choose where to go can choose whether to put their kids in the schools, so that if you have a school that's mostly poor that's actually doing well, it might actually become over time swamped by affluent parents. And on the other hand, only, like in Menlo Park, I'm wondering how many people go to private schools, say, and that at the top end of the scale too, you only get good private schools in places where the Thibault sorting sort of only keeps out non-rich people.
Yeah, so I mean, there's sort of two pieces of this. One is, does that kind of stuff pose a problem for our descriptive analysis here? And the other is, what does that mean about understanding how we could improve schools or the processes that sort of produce this? I'm going to punt on the second one for now. And the first one, because our socioeconomic data comes from ACS data on parents of kids whose children are enrolled in the public school in that district, it's a good descriptive of the people who have chosen to enroll their kids in the district. Of course, there may be reasons why they chose that are related to their performance, and if those differ, say, by race or different across district, then that makes you sort of not want to interpret this in terms of like, well, if I sort of just randomly sorted people in a different way, what would I see? But in terms of just descriptive of who goes to the schools and what's the average achievement life, the data are for public school parents in that district. The questions about sorting are, I think, make it more complicated to draw sort of policy inferences from this. Because it's not clear that districts that are sort of above or below the line are necessarily better in some sense. It may just be that their populations differ in ways that we don't have measured. It may be that the communities have resources or don't have resources that affect kids' early development, and that shows up, by third grade, but it's not due to the K-12 system. So I think it's important to not think of these as measures of the quality of the K-12 public school system in any place. They are measures of the, sort of mid-childhood academic performance of kids who live in this place. And that is the end result of a lot of stuff. It's the end result of, things they get in early childhood at home, things they get in preschool and childcare and other settings, as they grow, and things that happen in the K-12 system. And so so my big worry in putting these data out publicly is that people will just rank them. They'll say, oh, well, I should go to this school district because its dot is higher than that one. And these are not in any sense a value-added estimate or a quality estimate. These are a description of how well the kids who are there perform on standardized tests. But what causes that is not clearly just about the schools. Raj?
Sean, this is a fantastic data resource, and I think it'll benefit all of us. I have one question about the interpretation of the achievement gaps that you showed. So take the Berkeley example, has a very large achievement gap. That's partly because, as you explained, there's a lot of diversity within Berkeley. So one way in which you could mechanically reduce the achievement gap is basically to split up that school district. If you separated the lower SES kids from the higher SES kids, you'd mechanically end up with smaller achievement gaps. So
Right.
How do you think we should be interpreting the fact that Berkeley shows up high there? Is it, one view is you're not doing as well for one population relative to another, but another is just that you've got more diversity within the district, which might actually be a positive thing, right?
Yeah, it's clearly more socioeconomically diverse in the sense of the blacks are not nearly as affluent as the whites in Berkeley. That's why it's way over here on the picture, right? And so sure, if we sort of built districts that were sort of poor blacks and poor whites and middle class, we would end up with more districts here, and achievement gaps within districts would look smaller, but we might not have changed anything in the big world, right? That's part of why in the last slide I showed you, I look at the metropolitan area achievement gaps, because I think the metropolitan area is sort of a better way to think about the kind of broad structure of opportunity in society, because you have sort of all the stuff about people choosing where to live and the fragmentation of school districts and all of that sort of stuff is largely subsumed under, obviously there's some between region sorting and whatnot, but a lot of the sorting happens inside a metropolitan area, and so in some ways those are a better description of the kind of broad levels of unequal opportunity and outcomes you have in society. So it's sort of not fair to call out Berkeley, except that this is a Stanford-Berkeley conference, so I thought I should. For those reasons, I sort of think the metropolitan area is sort of a better way to think about the forces that produce this. I'm going to go to this side of the room. I'm going to go over here. Peggy?
I do really need that kind of thing. I just want to echo everyone else's comments, Sean. Wonderful, wonderful data. Is this better? Okay, thank you. Well, my own interest in this is so varied, but I recently saw some data that 61% of elementary schools principals that were surveyed now have responsibility for pre-K or preschool, so direct responsibility or contracted responsibility. And I'm wondering, as you go forward with your data, will you be able to look at, first just those districts that do have that and what the achievement gaps look like? And then, of course, what matters most is the quality of those preschool environments. Is
Right.
that something you're going to be able to do?
Yeah, so I would love to do that, but I would love even more if someone else would do that. I mean, part of the reason for putting the data out publicly is that, 250 million test scores, you could learn a lot. You could learn a lot more than I could learn in an entire lifetime. And so my hope is that lots of smart people like you guys in the room will think of ways to sort of say you find some exogenous variation in the timing of the provision of preschool in different districts. You could link it to this, you got 10 cohorts and sort of see if you can identify downstream effects of that sort of stuff. You could, any sort of exogenous kinds of policies that you could identify that affect some places at different times or different grades or different subgroups or something, then others could sort of link to this and think about ways of using that as a way of trying to identify those effects. And my hope is people will be really creative. And I should also give a little plug. So the Russell Sage Foundation, the William T. Grant Foundation are going to give small grants to young scholars to do research using these data, and that RFP will get announced sometime in May or June, I think. So if for graduate students or junior faculty or other folks, those foundations are going to provide some money for people who want to use the data for research, similar to they did with Raj's equality of opportunity data. So my hope is people will kind of think of questions like that and identify ways to answer them.